Hi, I'm Dave Watts. Welcome to the third part of GSA 50, Basic Indexing and Serving. In this session, we'll learn how to configure web crawling. We'll also learn how feeds work and when you'll use them to push other types of content. And you'll learn how to configure user experiences for serving results. To make content searchable, the appliance needs to first fetch and index it from your servers. To crawl web content, that is, content on a web server, you'll give the GSA one or more start URLs. The GSA will visit these URLs, fetch the document at each of them, parse that document to find links, then follow those links. This will continue until the GSA has visited all of your links or until the license limit has been exceeded. Start URLs must be fully qualified URLs. To prevent the GSA from crawling links to other sites, you'll give the GSA one or more follow and crawl patterns. Every URL the GSA discovers will be matched against the list of follow and crawl patterns. If it doesn't match any, the GSA will not visit that URL. The GSA will find any documents available through links. It will not find documents that are not linked targets. It also won't submit HTML forms or execute JavaScript to find documents. In this example, one start URL is given for server host1's home or root page, http://host1. That page and any links found to documents in the HR directory will be fetched and indexed. In the home page, links are found to two documents in the HR directory, so they'll be fetched, parsed for more links, and indexed. Doc2 has a link to Doc4, so it's also indexed. However, there's no link to Doc5, so it will not be indexed even though it resides in the HR directory. The GSA uses the URL as the unique identifier for each document. If two URLs lead to the same document, the GSA will consider them as two documents. As mentioned earlier, each URL must match at least one follow and crawl pattern. URLs can also be excluded using do not crawl patterns. These patterns don't have to be fully qualified URLs. Instead, they can be simple string patterns or regular expressions. Even simple patterns can use some special characters. The hash denotes a comment, the caret denotes the beginning of a string, and the $sign denotes the end of a string. When specifying a directory path, make sure you include the trailing slash, or you may only get the directory page and no other documents in it. Start URLs, follow and crawl patterns, and do not crawl patterns are all on the same screen in the admin console. Let's say I have two websites I want to index, www.learngsa.com and athens.learngsa.com. I'll need to give the GSA those two URLs as start URLs. Then, I'll need to specify one or more URL patterns to capture all of the URLs on those sites that I want to index and exclude the ones I don't want to index. For example, on these sites, I may have links to google.com. I don't want my GSA to start indexing those. In this case, since both sites are in the same domain, I can simply add one pattern This one pattern will match any URL that contains this as a substring. It will include HTTP and HTTPS URLs and URLs to other hosts within the learngsa.com domain. If I wanted to exclude other hosts, I could create one pattern for each site or I could add individual sites to my do not crawl patterns. In the do not crawl patterns, we can see many entries already exist. The GSA will automatically exclude files that it can index effectively, such as images and rich media files. We can add other entries here as well as needed. Once I've finished, I can just click the button to save changes in all three fields. If there are any inconsistencies, such as a start URL that doesn't match the following crawl pattern, an error will appear and our changes won't be saved until the problem has been resolved. Once you've entered your URLs, the GSA will immediately start crawling. After a short while, you can visit crawl status to see how the GSA is progressing. You'll see a chart like the one here. The yellow line indicates the number of URLs found, and the red line shows the number crawled. Over time, these two lines should meet and flatten as all the URLs are found. If content is being added, you will see these lines continue to rise. If they continue to rise at a rapid rate, you may have entered a spider trap where a potentially infinite number of links may be found, as shown below. The calendar is a canonical example of a spider trap. You can also go to Crawl Diagnostics to see information on each individual URL requested by the GSA. You can easily identify common crawl problems here, such as server errors like 404s and 500s. Real-time diagnostics can be used to help identify problems with individual URLs also. Let's take a look at those items. My GSA has crawled some documents, so when I visit crawl status, I can see the summary of crawled content. At the top, I can see a snapshot of crawl data. Below that are the charts mentioned previously. Now, let's look at crawl diagnostics. I'll drill down into the host, then into the folders, until I get to the documents. From here, I can see the status of the documents in this folder. The last one, for example, shows a 404 error indicating it's the result of a broken link. Let's look at an individual document that was crawled successfully. Now I can see additional information, such as the crawl history and documents linking to this document. Finally, I'll go to real-time diagnostics. This is one of my favorite tools for identifying crawl problems. Real-time diagnostics has several features. Let's look at the very first one. This feature takes a URL and attempts to connect to it. The URL doesn't have to be in the index. To use this, all I have to do is enter a URL and press the Fetch button. The GSA then attempts to fetch the URL and shows the response headers. This is the URL that didn't work from the GSA, and I can see the 404 status code here as well. The GSA will continuously crawl your content and will identify how frequently each piece of content changes. Content that changes more frequently will be crawled more frequently. Each URL will have its own individual crawl schedule. If documents are deleted from your web server, the GSA will discover this when recrawling those documents. You can configure the GSA to remove them immediately upon the GSA receiving a 404 status code indicating the document can't be found, or to try multiple times before removing the document from the index. While the GSA will generally determine the optimal crawl rate for your documents over time, you can push it in the right direction using freshness tuning. There are quite a few other index settings that can be adjusted. You can limit the number of URLs that the GSA will fetch, the maximum file size of those URLs, the amount of text to be indexed within a file, and how quickly the GSA should retry a URL that returns an error. Host load settings can limit the number of concurrent requests the GSA can make across all the servers it crawls, or individual servers. Finally, the GSA by default will use last modified HTTP response header to identify document dates. If you have content generated by an application server, this value is often missing. You can provide an alternative location for this value, such as an HTML metadata element. Document dates are very important. They're used for scheduling recrawl, for sorting and filtering by date, and date biasing. So it's very important that you have valid, meaningful dates for your content. Let's take a look at recrawling content. We can recrawl specific URL patterns directly from Crawl Diagnostics. From this page, I can recrawl this URL pattern by clicking the Recrawl This Pattern button. There's also a separate screen just for handling content freshness tuning. Here, there are 4 boxes. The first 2 boxes simply let you increase or decrease the crawl rate for a given URL pattern. The third box tells the GSA to recrawl documents regardless of the dates of those documents. It is extremely common for dynamic web servers to return incorrect dates or no dates at all. The last box lets you enter URL patterns that will be recrawled almost immediately, just like we did a few minutes ago in Crawl Diagnostics. If the GSA can't crawl your content, you can bring that content to the GSA using feeds. There are many common cases for feeds. Some systems just aren't crawlable. They may use JavaScript or HTML forms for navigation. Many content management systems don't expose document metadata. It's stored in an internal database. In addition, feeds can provide document permissions for secure content. We call those access control lists, or ACLs. You can also use feeds to limit the documents to be indexed. For common systems like file servers, SharePoint, and databases, Google provides connectors. Connectors build feeds for you and can handle other tasks like scheduling updates. If you decide to build your own feed, some coding will be needed, which we'll discuss in a later module. To use feeds, you'll have to configure following crawl patterns, and you'll have to allow your feed client to connect to the GSA. By default, the GSA won't allow any external machines to connect to it. You can change this in the Feeds Admin Console page. The second screenshot on this slide shows that portion of the Feeds Admin Console page. For following crawl patterns, the value you enter will depend on the feed type and source. For metadata and content feeds from a feed client you build, the URLs within the feed will have to match a following crawl pattern, just like they would if they were discovered through crawling. For content feeds from a connector, there are 2 common patterns used: Google connector, and the localhost 7886 URL shown here. Older connectors tend to use the first one. Newer connectors tend to use the second. The first screenshot on this slide shows that portion of the Follow and Crawl Patterns page. Once you've prepared the GSA to accept the feed, you can submit it from your feed client or connector. On the Feeds Admin Console page, you can check the status of your feed. Then, you can visit Crawl Diagnostics to view the documents from your feed. The two screenshots at the bottom of this slide show status information from the Feeds Admin Console page. Whether crawling or feeding documents, there are a number of problems that can occur. One common problem is that specific documents can't be found when searching. There are many reasons why this might happen. A list of common reasons is shown here. These include the file being larger than your GSA allows, having more text than the GSA will accept, and being excluded by Do Not Crawl patterns. One thing you'll want to check as a matter of course is the robots.txt file for any site you crawl. First, this file can't require authentication. When you request it with your browser, you should either get it, a 200 status code, or there shouldn't be any robots.txt file at all, a 404 status code. Then, of course, you might have rules in robots.txt that instruct crawlers to exclude various URLs. The GSA will obey these rules. You may need to change robots.txt to crawl the documents you want. Another common problem is files that don't have standard HTML links pointing to them. The GSA will only follow links. It will not execute JavaScript. Finally, if you have password-protected files, the GSA will need the password to open and index those files. We'll talk more about secure content in the next section, but if you have PDFs that require a password to be opened, you can set that within the GSA. If you have a URL you can't find in search results, first, make sure the URL actually exists on your web server and contains what you expect it to see. You can test this from a browser. Within your browser, disable JavaScript. You might also use browser extensions that let you change your user agent to what the GSA sends, GSA-crawler. This will show you what the GSA expects to see. If you get back what you expected in your browser, your next step should be Crawl Diagnostics. See if the document is in the index at all. If the document is in Crawl Diagnostics, check the cached copy to see whether it contains what you expected when it was last indexed. If it's not, identify why it was excluded. Crawl Diagnostics may tell you this directly, or you might have to investigate further with real-time diagnostics. Real-time diagnostics will allow you to request the URL from the GSA and show you HTTP request and response headers, as we saw earlier. Finally, you can use search operators if you don't have access to the admin console. The info operator shows you whether the URL is in the index. The link operator shows you which pages link to that URL. Now, let's run a basic search for the content that we just crawled using the default search on the GSAs. So here I am on my search page, and I'll search for medical. And I can see I get back several items. This is the default search interface without any customization. To view search results, users will interact with a front end. You can create multiple front ends, and each can behave differently. Front ends can control the appearance of the display, and the behavior of the search. You can use the front end for serving results directly to the user, or you can build your own web application off of the appliance and have that application interact with the GSA on the user's behalf. You can return to the first section of GSA 50 for examples of each. The two screenshots on this slide show two different front ends. The first is basically a default front end with some features turned on, while the second has been customized to use the same HTML as the main website. To create a new front end, simply go to Serving, then Front Ends. You will have one front end already by default. The display can be customized from the first tab, Output Format. There are two ways you can customize it, the easy way and the hard way. The easy way is to use the Page Layout Helper. This wizard will let you make many common changes through a simple GUI. You can customize the HTML header and footer as well. For many users, all the changes they want to make can be made through the wizard. If you need to make additional changes, you can edit the code directly. The GSA uses XSLT style sheets to rewrite the raw XML results into an HTML page. This is programming, and you should know the basics of XML, XSLT, and XPath if you want to do this. Everything about a search is controlled by URL parameters sent to the GSA. To choose which front end is used for a given search, there are two URL parameters. The client parameter controls which front end is used for all the tabs except for the first, key match, related queries, filters, and so on. This parameter is required for every search. The proxy stylesheet parameter controls which front end is used to display search results. If this parameter is omitted, the results will be returned as raw XML. Let's take a look at this process. First, I'll create a new front end. Now I'll edit that front end and change some settings under Output Format. I'll change the logo under Global Attributes. Then I'll remove the Secure Search option under Search Box. And then I'll remove the bottom search box under Search Results. Finally, I'll save my changes. Next, I'll use this new front end, Demo Front End, by going to the GSA Search Web Server. Watch what happens in the location bar of my browser when I go to the URL. Note all of the URL parameters that were appended automatically. These control every aspect of the search. We can also see the default appearance of the search page. Here's the logo that I just changed. Note the client and proxy stylesheet parameters pointing to Demo Front End. Now, if I make changes to this style sheet, I can go to the end of my URL and add an extra parameter, proxy reload equals 1. That tells the GSA not to use a cached copy of the style sheet. So we can see our new logo and no search box at the bottom. Let me run a search. And finally, let's see the raw XML. To see that, I'm going to remove the proxy style sheet parameter. This XML can be easily parsed by an application server. The GSA has a single index. All documents go into that one index. But you can filter documents based on predefined sets of URL patterns to help users narrow search results. We call those collections. By default, there's a single collection that contains everything, but you can create up to 300 additional collections. At search time, the GSA looks at the site URL parameter to see which collection to use. Each collection can specifically include or exclude whichever URL patterns you want. In the page layout helper, you can add a collection menu. You can also specify more than one collection in a search using the dot operator for and the pipe operator for or. The example shown here will find any documents that are in the prices collection and in either the products or services collection. Collections are not just used for searching. All of the reports that the GSA generates rely on them too. Because of this, it's very important that you not delete or modify the default collection. If you do, you won't have an easy way to get reports that include all of your documents. Let's create a collection. So to do that, I'll go to Crawl and Index, Collections, add a collection name, edit that collection, and I'm going to include a single URL pattern, one of the 3 URL patterns indexed by this appliance. Click on my Save button. When I return to Crawl Diagnostics, you'll notice that it shows both collections. However, the new collection I just created doesn't have any content under it yet. It generally takes a little while for the GSA to recategorize things as members of a new collection. When the GSA has done that, I'll be able to go back and run a search and filter on that collection. So again, I would be looking for the site parameter, and I would change that to demo_collection, since that's the name I created. Because my documents haven't been retagged yet, nothing shows up in the search, but later on it will. This concludes our third presentation, Basic Indexing and Serving. In it, we learned to crawl web content, feed other content, and configure user experiences with front ends and collections. Thank you for watching, and make sure to watch the other GSA 50 presentations.